Hello students, welcome to Ahuja classes Smartness in Education. Today we are going to learn the next concept of number system, that is the numbers and their decimal expansions. In this lecture we will learn how the real numbers are represented in the decimal form and the various patterns followed by them. Let us see some examples. The first example is, let us see the decimal expansion by using some examples. The first is 10 by 3. That means we have to divide 10 by 3. So in this problem we can see the division of 10 by 3 as, here we will use decimal, 3 3 are 9, remainder is 1, again there is one remainder, so here we will obtain 3 again and again. So the decimal expansion of 10 by 3 is 3.3 bar, or 10 by 3 as 3.333, and so on. Now let us see the another example, that is 7 by 8. 7 is smaller than 8, so that we will use decimal point before it. 8 8 ja 64, remainder is 60. 8 7 ja 56, remainder is 4. 8 5 ja 40. So here the decimal expansion of 7 by 8 is written as 0.875. Let us take the another example, that is 2157 divided by 625. 2157 divided by 625. In this example we have 2157 divided by 625. So the division can be written as 6 3 ja 1875, and the remainder will be 282, and we will use decimal expansion over here and we will use 0. So 6 4 ja 20, 500, and the remainder is 320. So again it is not divisible, so we will use 0 here. 625 5 ja 3125, and the remainder will be 75. Here again it is not divisible by 625, so that we will use 0 over here. Now 625 1 ja 625, and the remainder is 125. This is not divisible by 625, so we will again use 0 over here. 625 2 ja 120, 1250, and the remainder is 0. Next example is 22 by 7. 7 3 ja 21, remainder is 1. It is not divisible by 7, so that we will use 0 over here, and we have applied a decimal point. 7 1 ja 7, remainder is 3. 7 4 ja 28, 2. 7 2 ja 14, remainder is 6. 7 8 ja 56, 4. 7 5 ja 35, remainder is 5, 0. 7 4 ja 7 7 ja 49, remainder is 1 again. So again we will get the same decimal expansion or same decimal representation. So we can write 22 by 7 as 3.142857 to the bar, or we can write, or 22 by 7 can be written as 3.142857, 142857, and so on. So this part is the one which is being repeated again and again. The next example is 3 by 20. Let us see the decimal expansion of this number. 3 divided by 20. 3 cannot be divided by 20, so we will use decimal expansion and we will use 0 over here. 21 ja 20, remainder is 10, which is again not divisible by 20, and this will be 25 ja 100. So we can write 3 by 20 as 0.15. Here we have seen that in the sum examples we got the repeated decimal expansion, or the decimal expansion is in repeating nature and recurring nature, and in some examples we have seen that the decimal expansion of some rational numbers is either terminating. So here there are two cases. In some cases we can see the decimal expansion as terminating, or in some cases it is non-terminating but it is recurring in nature. So let us see the pattern followed by these examples. The first case was 10 by 3, we got 3.3 or 3.3 bar, or as 3.33 again and again, which is being repeated. In the second example we have obtained 7 by 8 as 0.875. In the third example we have obtained 2157 by 625 as 3.4512, and in the fourth example we have obtained 22 by 7 as 3.142857 to the bar, or we can write it as 3.142857 142857 again and again. In the fifth example we have seen that 3 by 20 as 0.15. So here this decimal expansion was terminating in nature, this is again terminating in nature, fifth one is again terminating in nature. In these three examples there is a basic concept. Let us see the denominator of each of these expressions. In the denominator of these three examples there is either the denominator is in the form of 2 to the powers, or in the form of 5 to the powers, or it is the combination of the powers of both 2 and 5. In the second example the denominator is 2 to the power 3. In the third example it is 2 to the power, it is 5 to the power 4. In the fifth example it is 2 to the power 2 into 5 to the power 1. So we can say that from these three examples that the decimal expansion of any fraction is terminating only when it is in the form of denominator having powers of 2 or powers of 5 or the combination of the powers of 2 and 5 both and no any other number. So we can write it as any fraction has terminating decimal expansion only when it has denominator in the powers of 2 or in the powers of 5 or in the combination of both 2 and 5. Now let us see other examples which are in the form of other numbers like 10 by 3, 22 by 7. So here the denominators are not in the combination of 2 or 5 or not separately in the form of 2 or 5. So if we have any rational number or any fraction in the form of p by q, then its decimal expansion will be in the form of non-terminating in nature, but it will be in recurring nature. That means a particular number or a group of number will repeat again and again in its decimal expansion. So we can say that fraction has non-terminating but recurring decimal expansion when its denominator is in the form of powers of any other number except 2 and 5. So if there is any other number is present other than 2 and 5, then it will be in the form of non-terminating but in the form of recurring decimal expansion form. So in other words, we can write it as fraction is non-terminating but recurring when its denominator has any other number with or without the powers of 2 and 5. So we can conclude that the decimal expansion of a rational number is either terminating or non-terminating, but it is recurring in nature. So, in other words, a number whose decimal expansion is terminating or non-terminating, recurring is called rational numbers. In the opposite words, it is the number whose decimal expansion is either terminating or non-terminating, but recurring is called rational number. So, we can say that rational number is the number in which the decimal expansion is either terminating or non-terminating, but it would be in the recurring nature. And in the second case, the decimal expansion of an irrational number is non-terminating and it will be non-recurring. So if we write any example of an irrational number, then we have like root 2. Root 2 is the number which is an irrational number whose decimal expansion is given by 1.41, 42, 13, 56, 237, 309 and so on. The numbers are being repeated but they are not in the systematic form. So we can say that in general that the decimal expansion is non-terminating and it is non-recurring in the systematic form. So an irrational number is the number whose decimal expansion is non-terminating, non-recurring, is called the irrational number. Thank you. In the next lectures, we will learn about the conversion of decimal expansions in the form of p by q.